French. Well, not for the presentation, I hope, because otherwise I would be lost. So it's up to you, Lucía and Nikos, to talk about simplification.
Thank you very much. So, hello everybody. I first want to thank Swiss Text for giving us a chance to share and to present our work with you today. So, my name is Lucía, and I am currently a PhD candidate at University of Geneva. And today I will be presenting some of the work that I have conducted with Nikos Tsourakis in the last few months. Our idea was to create resources for text simplification, which is rather a low resource task in French. And for this reason, we worked in the creation of a filtering method to extract complex to simple sentence pairs from comparable corpora. So we will first start by introducing the field of automatic text simplification, and by giving a brief context and motivation for our work. In section 2, we will discuss how we collected the data for our experiments. That will be explained in section 3. And then we will move on to the results and wrap up everything in the conclusion. So what is automatic text simplification? Well, it is precisely what the name suggests. That is, rewriting a version of a text where the idea is that we want to reduce the linguistic complexity of it while still retaining the original meaning and information. In some way, we can imagine this process of simplification as a question of form and substance, where the idea is that we want to change the form, the appearance of the text to reduce its complexity, but we still want to maintain intact as much as possible the underlying meaning, that is, the substance. Even if text simplification can be particularly interesting for text accessibility, automating this task is particularly problematic because of the scarcity of parallel yet monolingual corpora that associate complex to simple sentence pairs, and that would actually allow for the training of supervised simplification models. This is even more noticeable in less resource-rich languages than English. Like, for example, when it comes to French, even if it's a relatively well-resourced natural language, there is only one dataset available for simplification, a lector, which was manually created by professional editors. And there again, even if manually created datasets provide high quality and very reliable simplifications, the compilation process is very expensive, and the resulting datasets usually have a very compact size, which makes it insufficient for the training of ATS models, which seems to suggest the need to explore automatic methods that can help provide larger scale parallel datasets for ATS. And this is precisely what we have intended to do with this work. Since the lack of aligned data in French is quite a bottleneck for the advancement of the field, we decided to propose our own filtering method that can help extract parallel sentences. And to do this, automatic approaches typically rely on registered diversified comparable corpora that associate standard text with their simplified versions. So we chose to rely on the French editions of Wikipedia and Vikidia, where Vikidia is a simplified version of Wikipedia that aims at making text articles more easily understandable for children. But also, these automatic approaches, they tend to rely just on semantic similarity measures and tend to be oblivious to whether the target sentence is indeed a simplification from the original sentence or not. And for this reason, we decided to take into account the two conditions that a successful simplified sentence must meet, and to address them in a sequential manner. That is, we first verify if the Wikipedia sentence is semantically equivalent to the Vikidia sentence, and if that's the case, then we check whether the Vikidia sentence is indeed a simplified version with respect to the Wikipedia sentence. So, to mine parallel sentences, what we had to do was to first scrape the content coming from both encyclopedias, and we also decided to just extract the summaries in the prologue, which are also known as lead sections, under the assumption that there might be greater chances of finding aligned sentences in this part, given the typically definitional style of this part, and also the fact that Vikidia, being a simplified version from Wikipedia, is more likely to share snippets in the introduction, rather than in the rest of the article. So what we did was to first extract the URL list of all Wikidia articles, Then we parsed the HTML content to find the interlanguage links to the corresponding Wikipedia articles. And in this way, we obtained the lead sections from Wikipedia and Vikidia that we then segmented into sentences using the Spacey library. This gives us about 165,000 Wikipedia sentences and 135,000 sentences in Vikidia that we then fed to the first filtering stage that Nikos will be introducing now.
Thank you, Lucía. So after the data acquisition part, it's time to present our two-step filtering approach based on the two conditions presented earlier. First, retain the original meaning and information, and second, extract the simplicity gain with respect to the reference. Our approach is sequential, which means that we apply both filters for the two conditions. Let's start with the first filter. Having at our disposal a large amount of sentences, as we see here, the aim is to extract those pairs that are suitable for ATS. For that reason, we resort to SBERT, which is a method for generating fixed length sentence embeddings. It uses multilingual sentence transformers from Hugging Face. However, there is one certain problem, the fact that we are not really certain if one pair is sufficiently semantically consistent. And for that reason, we had to solve a sub-problem, which is identify those pairs that exhibit a high semantic overlap. Let me give you a few examples from the sentences that we scraped from the web. Of course, these are translated versions from French to English. If we check the first pair, we will agree that most of the meaning is retained to the Wikipedia part. However, when we check this pair, we observe that part of the information is lost. Specifically, the fact that this person is a producer and is born in one specific place and one specific time. Right. And even worse, the information in the third example is completely lost, except perhaps the word information itself. Right, so in order to find the proper SBERT threshold that will allow us to identify those sentences with a high semantic overlap, we resorted to a manual annotation. So we first selected randomly 500 samples from our initial data set, and we asked two annotators to determine whether a pair conveys the same meaning. A valid label signifies that the meaning is fully preserved. Partially valid tells us that some of the information is lost, whereas the non-valid label signifies dissimilar sentences. After we analyzed the output of this annotation, we managed to extract a mean SBERT score for the valid case equal to 0.81, which we consider as the cutoff threshold for semantic filtering. So the output of this process is essentially a corpus of sentences that exhibit a high semantic overlap. Of course, having similar sentences doesn't imply that these are also valid simplification pairs. So we had to introduce a second filtering step. But before I explain what happens inside this filtering, let me introduce the concept of gain. Gain signifies the absolute difference between a feature value and in the source and the target sentence. including polarity. So let's say that we have a sentence with 8 words, and this becomes 6 words in the Vikidia target. The gain in this case is -2. So the general idea is what? Is to devise a set of features, and from these features calculate a table of gains that we can use for training a binary classifier to tell us whether a certain pair is a valid simplification. We devised in total 11 features that fall broadly under 3 categories. So, for instance, the sentence length is a structural feature, the number of name entities is lexical, and the non-nested distance is a syntactic one. Of course, all these descriptions can be found in the paper. Using these features, we trained a simplicity gain classifier, exploiting a data set with 180,000 examples from Wikilarge. Wikilarge is a very well-known data set for creating and refining text simplification models. Of course, this resource was in English, so we had to resort to Google Translate to acquire its French version. Then we extracted values of features independently for each article and combined them into a simple pair. We also split the data set into 2 halves, interchanging the source and the target. The reason was here to acquire both examples that demonstrate simplification and complexification for training the classifier. And in the end, we also calculated the gain values for each pair. So, after training the classifier, we assessed its performance. On the left, I have again the table with the features as a reference, and on the right, the classification performance. We can observe that even a single feature, the sentence length, is a good indicator of simplification, which makes sense, right? Shorter sentences tend to be simpler. Adding the CEFR score into the mix, we get a slight improvement. The CEFR score is a standardized measurement to assess proficiency in a language in six levels from A1 to C2. And little by little, combining all the features together, we end up with this performance where all the 11 features take part. So, the data acquisition step and the 2-step filtering approach allowed us to create WiViCo, the WiViCo dataset, which is one of the contributions of our work. So let me say just a couple of things about it. WiViCo is a monolingual parallel corpus, and it has a distinctive feature, the fact that by tweaking the output of the classifier, we can get different number of simplification pairs using either lenient or stricter thresholds. And in this table, you can see such an example. As the classifier is more confident about its output, we get less simplification pairs. And when its confidence goes down, we can get much more. And that way, researchers can exploit this feature for their own work. The WiViCo dataset is available under this GitHub repository. Notice that this is not a static repository, and we tend to include new variants of the WiViCo dataset in the near future. So interested researchers can take a look on this repository and put the radar for their work. And with this, I pass Lucía for a few final thoughts.
Yes. So with this work, we conceived a method to mine comparable corpora to extract relevant parallel sentences for ATS. And the idea behind this 2-step filtering process, as we said, is to sequentially address the 2 main conditions for a simplified sentence to be considered valid, which is first the preservation of original meaning that we checked with the use of expert cosine similarities and a manual annotation, and then simplicity gain with respect to the reference that we treated with a sentence complexity classifier. And by using this approach, we were able to produce a parallel data set, WiViCo, which is now available on GitHub, and that we intend to use to train sequence-to-sequence ATS models for French, or to fine-tune pre-trained LLMs for our downstream task. And also, another idea that we're exploring at the moment is how to enhance the simplicity gain part. In this presentation, we were speaking about a binary classifier for sentence complexity, but simplification is inherently a relative process. We simplify with respect to a reference text, so a binary label seems somewhat insufficient. And this is why we're exploring how to quantify the simplicity gain achieved within a pair of sentences by fine-tuning BERT models for classification and regression tasks. And that's it for today. Thank you very much.
Are there any questions? Yeah.
In your system classifier, you are using both the sentence length and the number of words. For me, it's the same, no?
It depends, because the sentence length is calculated in terms of the number of characters, and then there's also the number of words. So we're using both. That's the difference. It's a character-based Levenstein distance and also like a word-based Levenstein.
Yeah, because I'm expecting something about the mean length of the word. Because usually long word is more complex than short one. So
Yes.
Some that can be captured by the other score, the CEFR. But that's about it.
I have a question on that one, because if you go back to slide 6, it was, I think, the statistics of your corpus, there the word length seems to be longer for the simplified text.
It's here. Yes.
This one.
Compared to what you mean?
The average word length in the simplified text seems to be longer than in the Wikipedia.
I think it must be a mistake, because now
Okay.
I'm seeing the text token ratio is 8:25, so I might have made a mistake
Okay,
when I
just
was
copy
copying
paste.
the.
I was wondering.
That's right, I'm sorry about that.
It's a good catch.
Yeah.
No, but I think it was lower than the Wikipedia text, but I made a mistake in placing the numbers. Yes, but I can check that in the article.
So thank you very much for your talk. More curiosity, or maybe a suggestion. I can imagine that what you're developing could be very much of interest to Wikipedia editors for their work. Have you considered being in touch, or are you in touch with them? Maybe set up an experiment and see what works, what works.
Well, we actually tried to contact the people behind Vikidia in order to get the dumps from the official dumps from the Vikidia articles, but we were not successful.
Yes, unfortunately not.
So we had to resort to other methods for scraping the data. So we tried, but well.
Okay.
Thank you for your talk. Two questions. First question, I think I missed it, but by how much did you now grow the availability of the data set? So you mentioned before there was only one data set before. How big was that? And how much did you increase it by now?
Yes.
And the second question is, you use SBERT for sentence similarity. I guess you use the out-of-the-box SBERT, but have you also considered trying to have a fine-tuning step using the available data set already?
That could also be an interesting thing to test. When it comes to the size, we now have released in our GitHub repository a first version of WiViCo, where we just have like parallel sentences coming from the lead sections, as I said before, like coming from the initial summaries of Wikipedia and Vikidia. But the idea that we have now that we want to explore is also, even if we have this hypothesis that we might find more aligned data in the beginning of the article, we also want to test if we can get more data on the basis of the whole articles from Wikipedia and Vikidia. That's yeah, something that we plan to do.
Yes.
Any more questions? not, then let's thank the speakers again. Upstairs, if you go